How you going, guys? Curtis from Cutting Edge Engineering. Today's job we have something a little bit different. So I have a customer that has a couple of helicopters and he's asked can we please make them a spacer to mount underneath the aircraft to hold a camera mount. It's not a big job, it's not complicated, it's just one of those little jobs we get through the workshop. If you take a look down here, I'll show you what it looks like. So it looks like a Millennium Falcon. This is a aerospace grade aluminium. The way it works is that gets mounted up underneath the aircraft and there's about a $500,000 camera that hangs off this. So all we need to do is make up a 20mm thick spacer that suits that center pattern there, just to space it off the aircraft for when they're doing their testing of this camera. Once they've worked out and they've tested it and made sure everything works, they will then have a spacer manufactured to the right height. They'll delete this one here off the actual frame and they'll make one the right height they need. They just need to test this thing to make sure everything's going to work. And these cables that suspend the two, that is the shock absorber that removes any vibration as the aircraft is running and they're trying to film. So what we're going to use for this, we've got a piece of 160mm, 25mm thick machine grade aluminium. So what we're going to do first, we're going to set it up in the lathe, we're going to face it off, turn it around, face the other side to size. We're going to bore out the center to 3" and then we need to grab it from the inside and then we need to turn the OD down to 5.5". Then we've got 8 holes to drill in. First thing I'm going to do, going to go get it set up in the lathe and I'm going to start turning it. Sticky material. Because this spacer is not super critical on the thickness of it, and it's going to be quite hard to get a measurement from the edge of that on my calipers, all I do is I just bring the tool in, I touch off the inside jaw, what I'm going to back this piece of material out to, touch off on that gives me a 0, come out 20mm and I'll face it off. So quick and easy way to do it, being that this is not a production part, it's just for testing. They said give us a spacer about 20mm, so 20.1, 19.9, either, it'll be fine. Still hold it a bit high. Righto guys, so we've completed the machining on the inside, we've faced it, we've got it to the ID and the thickness. Now we need to machine the OD. Because my jaws of my chuck can't go down so I can fit the plate over the jaws, I need to make up a mandrel that I can put the plate on, then support it with the tailstock and just use basic friction to keep it in place, and then I can machine the OD down to size. So what we'll be using is a piece of 3-inch induction hardened chrome bar. I have a plate here that I put a live center in. I push that up against the job using the tailstock, and then I use basically that plate to drive the plate I'm machining. So we're going to get that set up now and show you how it's done. It's probably not the best way to do it, but I don't have a plan B, so this will work. Not bad for a touch-off job. Righto guys, so we've completed all the turning that we need to do on that spacer. We do need to drill the 8 holes in it now. I will be using my super indexer. Super indexers, for those who don't know, are basically a rotary table, except in the super indexer you have multiple plates you can put in the back of it to do 8, 6, so on and so forth, holes all accurately. So all you have to do is pull the lever, spin it around till its next notch, and then you can drill the hole, and we'll end up with 8 perfectly spaced holes. A few people mentioned in the last time I used my super indexer, why don't I just use my digital readout? I got brought up with one of these. Our machines where we used to work didn't have digital readouts on them. I waited a long time to get this. Now that I have it, I'm just going to enjoy using it. So we're going to set that up. Sensitivity 121.9. 121.9. $60.95. Righto guys, so we've got it set up in the super indexer now. We used our little wobbler center finder to find the center of the part. Now that that's done, I've got the hole spacings. Now we have to do is just offset it and we can drill in our 8 holes. So we've taken our hole spacings, which is 121.9, divide that by 2, advance the table over to 60.95. From where we are now is our hole spacing. Deburr these holes. Problem with Ali, grubby fingers stand out forever. Righto guys, we've completed our little spacer now. From start to finish, a job like this will generally take about an hour. That includes all your setup time. All in all, pretty quick little easy job. Turned out pretty good, pretty happy with that. The customer's going to be happy. They'll be able to do any testing and making sure things work on the aircraft that this will be mounted on. It could be as simple as they just needed a bit of extra room to get around something on the aircraft, or they've changed out the gimbal mount or something like that. This won't actually be flying in the air, hanging off a helicopter. This is solely just for the positioning of the camera underneath the machine. Once they've proven that it works, that everything moves where it's supposed to, engineering will happen. Someone will then redesign the part, removing the first spacer that's already on here. Someone will then manufacture that out of the correct material. It'll be anodized and fitted on the machine. Still pretty cool that we can help and build a little cheap component for something that's worth $500,000, and we'll be flying around our skies here in Australia. So very cool, job done. Ready? 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 Ready?
Yep.
So, ready? So, yeah. We'll bore out the center oh fuck man. Oh fuck. Hard talking in bananas. 5.5 mil in diameter, or 730 seconds I think they were. I think.
Freaking banana talk.
Fuck yeah, it's confusing. 5.5 mil so easy, 730 seconds, that's retarded.
What the hell?
What were they thinking?
Is that time? Are you talking in time?
I don't
730
know.
seconds. Oh,
Is it
anyway.
coordinates to somewhere? Who knows? I probably spent 15 minutes looking for the piece of material. I knew it was here, I just wasn't sure where. There was sticky material. Sticky shit. Oh, you're fucking kidding me. Here we fucking go. Hey mate. What's happening? Not bad for a touch-off job.
Touch-off job.
Touch-off job. So that's why I'm using it.
Very good.
So
take that.
fuck you haters.
Did you actually? I need to go slow-mo that footage. Oh. Oh.
You're gone forever. Always make sure your table's locked before you drill your first hole.
Yep.
But I want to explain a bit more about the rig.
Okay, so we'll go back down to that then.
I'll hold it.
Okay.
Righto.
Okay, you haven't talked about that yet, so...
Fuck's sake.
Well, you haven't... I didn't say put that in the... Just like... I don't know. Are you going to be using that boring bar?
Yes. You're going to know the way.
Yep.
I should explain that actually.
What? Yeah, what did you just do?
Ready?
Well, no. What?
We can go 60.95 this way or that way, and it'll still pick up the hole centers.
What do you want to... Do you want to somehow explain what you've just done?
Right.
So much shine. What are you doing?
Can I take it out now?
Oh, yeah. Come on. Good boy.